In this video, we are going to be discussing properties, and you may have learned some of these properties previously, but we're going to review some of the ones that you should know and the new ones that you're learning for 6th grade. So, the first one that we're going to talk about is the commutative property. And I'm going to use a highlighter so I can highlight the most important things here. So the commutative property is changing the order of the numbers, and you're doing that when adding or multiplying. And you'll notice with most of these properties, it's when you're using addition or multiplication. And it's the same thing for the commutative property. And the way we can remember the commutative property is by highlighting that CO. And the CO is telling us that we are changing the order of the numbers. So we have the commutative property is changing the order, and it's for addition or multiplication. So if we look at the first example that we have here, we have 3 plus 2 plus 1. If we change the order of that, it's going to be 2 plus 3 plus 1, or we could do 1 plus 2 plus 3. As long as you're changing the order of the numbers, you're doing the commutative property. Now we can do the same thing with multiplication. 5 times 8 times 7 could become 8 times 7 times 5. And then the reason why this works is because even if you do 3 plus 2, that'd be 5, plus 1 is 6. I'm still doing 2 plus 3 is 5, plus 1 is still 6. So it's still balanced on both sides of the problem. Same thing with multiplication. If you multiply 5 times 8 and then multiply it by 7, it'll be the same thing as if you do 8 times 7 and then do it times 5. So that's the commutative property. It's changing the order of the numbers. Now the associative property, the way that we remember the associative property is if you want, you can change the S's into a group of parentheses. So the associative property is changing the groupings in the problem. So we are changing the groupings without changing the order. So, and this is also for addition and for multiplication. So in the groupings this time I have 3 plus 2 and then I have plus 1 on the outside. We're not changing the order, so I'm just going to rewrite this 3 plus 2 plus 1. But 3 plus 2 is in the groupings the first time, 2 plus 1 is going to be in the groupings the second time. And the reason that this works is because the same thing with the commutative property, I'm just rearranging the problem by doing the groupings this way. And the same thing for multiplication here. I leave the order the same, but I'm going to change the two numbers that are inside of the groupings, which is 5 times 8. So the associative property changes the groupings, the commutative property changes the order of the problem. The next one we're going to talk about is the identity property, and the identity property is kind of like looking in a mirror, looking at yourself. So it's what number do I add to keep it the same and what do I multiply to keep it the same. So with the identity property, you're going to add 0 to keep it the same, or you're going to multiply by 1 to keep it the same. So you are keeping the value the same. So if we look at two examples, we have 3 plus 0 is going to stay 3. And then if we do 5 times 1, that's going to keep it 5. So you're just looking in the mirror and keeping the identity of the number the same. In this case, the mirror for addition is plus 0, and the mirror for multiplication is times 1. The inverse property is when you're doing the opposite or you're canceling something. And inverse means opposite. So you are undoing or canceling, and it's the opposite. So the opposite of addition is going to be subtraction or a negative number. So the opposite of addition is a negative number, and I'm trying to cancel this. So if I have a positive plus a negative, so I have a positive and I take some away, I'm going to end up with 0. So when you're adding, you want it to equal 0 to make it cancel. Because if there was something else here, if I did 0 plus 5, I'd still end up with 5 because it would be the identity property. So the whole thing with inverse is you want to get it down so that it works with the identity property. Then if we look at multiplication, multiplication's a little bit different because this is actually where our keep, switch, flip property comes from. So in reality, this would be written like this, 5 divided by 5. And then but division doesn't really exist in the math world or in fraction world. So I'm going to put them both over 1, but I'm not allowed to divide fractions, so I need to do keep, switch, flip. So I really have 5 over 1 times 1 over 5, which is what this is showing here. 5 over 1 times 1 over 5. So this is our keep, switch, flip property. Now if I do 5 times 1, it's going to be 5. 1 times 5 is 5. And then 5 divided by 5 is 1. So anything times itself with its identity property here is just going to stay itself, which is what I'm trying to do when I'm canceling. So when I'm multiplying, I want it to equal 1. So when you're multiplying, you can make this even a big dot. You want it to equal 1. The next property that we have is the distributive property, and you are passing out a number. So pass out to a grouping, and the rule is outside times the first, outside times the second. Now the word distribute means to pass out. So your teacher will distribute your tests to you whenever she is returning them to you, or he is returning them to you. So if we look at this problem, it's outside times the first number, outside times the second number. So we have outside times the first number, then I have the outside, and this is a positive 3, so we're going to put plus 3 times the second number. Outside times the first number is a 2, outside times the second number is a positive 1, so it's a 1. And that's all you have to do for distributive property. Same thing for this one. Outside times the first, outside times the second, outside times the first, positive 5, outside times the second. The first is an x, the second is a 2. So that's all that you need to do for the distributive property. And then the last one, the multiplicative property of 0, it says its name. All you're doing is you're multiplying by 0. And just really quickly, it's 3 times 0 is 3. And then the same thing here, it doesn't really matter what 8 times x is because it's then going to be times 0. Oops, I'm sorry, I made a mistake. 3 times 0 is 0, not 3. And the same thing here, it's still going to just end up being 0. So the multiplicative property says its name, and you are just multiplying by 0. So if we look at the next page, we're going to go through and we're going to name these properties, and you can use your other page for assistance. But make sure that you know whenever you take a quiz or a test, you're not going to be able to use that page. So it says name the property for each. So if we look at number 1, I have a negative 2, and then I have this positive 2, and it equals 0. If we go back and we look at our examples, we need a negative and a positive equals 0. That's this one right here. So this is the inverse property of addition. So we're going to write inverse of, oops, hold on, we're going to put prop of add. And you can shorten these a little bit. Just make sure you leave enough letters so that we know what you're talking about. If I do another example, if we look at number 2, I have a whole number times a fraction equals 1. And remember, lonely whole numbers go over 1 when you're working with fractions. So this is that keep, switch, flip property here. I keep the first, I switch to multiply, I flip it over. And if we look back at our examples, that is this inverse property of multiplication here. So if we go back, this is the inverse prop of mult. If we look at number 3, this one I'm multiplying by 0, and if I look back at my notes, I look at for the example, did I say multiplying by 3? I think I said multiplying by 0. So if I look back at my examples, I'm multiplying by 0 here. That says its name, so it's the multiplicative property of 0. Mult prop of 0. And number 4 is a little bit tricky. Number 4 I keep the order the same because it's A, B, C, and if you need to, draw a little dividing line here so on the equal sign. So this is ABC versus ABC, and it's in the same order, so order didn't change, but the numbers inside of the groupings changed. So if I go back to my notes, I'm looking for with no changing of the order, but I want to change the groupings. That's the associative property, and it's of addition because there's a little plus signs there. So it's associative of add. So what I want you to do is I want you to use your notes. You can help you with problems 5 through 12. When you're ready, unpause the video and we will give you the answers. So here are all of your answers for 5 through 12. I do want to look at number 10 because number 10 can be a little bit tricky. You're changing the order of the X and the Y. And remember, when numbers are smushed together, same thing with letters, that means multiplication. So this is the commutative property, and it's of multiplication because it's changing where the multiplication is. So that's why number 10 is the commutative property of multiplication. And then real quick, number 7, if you look at this one, 2 times x is 2x, just written that way. And then 2 times 3 is going to be 6. So that's why it's the distributive property there. So if you look at the bottom of that page, it's just a few true-false questions. So answer the following questions, true or false, then justify your answer. So what that means is if it's false, you're going to fix it and tell me what should be corrected. So 2 plus 0 equals 2 is an example of the multiplicative property of 0. Well, we're not multiplying, we're adding 0. So it's not an example of the multiplicative property of 0. That's false. So it's not this, it is really the additive identity property. And then same thing with number 14, 3x plus 4 equals 6x plus 8. It has parentheses, so it's an example of the associative property. Well, this is not an example of the associative property. This is actually, and there should be a little 2 squeezed in there. That's our fault. This is not an example of the associative property. This is actually an example of the distributive property because it would be outside times the first, outside times the second. 2 times 3 is 6. 2 times 4 is 8. So this should say the distributive property. So what I want for you to do now is I want you to try number 15 through 18 on your own. Pause the video and then I'll give you the answers. And here are your answers for numbers 15 through 18.